So last day I actually finish here. So this is the last class where actually I stopped my discussion. So the gain of an amplifier, AV equal to V naught by V in any time. But where is the V naught? V naught is not at the generator. V naught is the output of the terminal, where AV is the open circuit voltage gain. If the circuit remain open, V naught is same as AV, where AV is called the open circuit voltage, multiple of the V in. V in is the voltage across the RI. But sometimes the circuits look slightly complicated. That means there is a resistance at the output side that is called the load resistance, and there is a source, and the source has its internal resistance that is actually source resistance. We cannot draw any voltage source without a series resistance. It is actually Thevenin's theorem. For ideal case, maybe the voltage source internal resistance is 0. Now, I show you an exercise, or maybe you can say the example like this. We have a source has a resistance that is called the RS. It may be the 10 kilo ohm, and the source has the voltage. It is actually plus, minus, it is actually any voltage. I write down VI equal, I write down 10 millivolt. Milli means 10 to the power minus 3. Now it is connected with our amplifier. This is called the RI, input resistance of the amplifier, and its value is equal to maybe also 10 kilo ohms. Now we have the amplifier generator. Where is the plus, minus? It is actually AV into VI. And AV is given maybe 100. Now it has an internal resistance whose value is equal to R naught equal 150 ohms, and it is connected with the load. The load resistance is RL. Maybe it is 300 ohms. Now this is my V output. So where we can find out, I try to find out any different color, then it will be better. Now I draw this one. Now this is my amplifier. The blue dotted box is basically our amplifier. This is our amplifier. The rest of the circuit is not the amplifier. It is actually the input device and output device. So this type of circuit we will provide you in your exam and ask you calculate the voltage gain of the amplifier with respect to the source voltage Vs. One thing I make a mistake, it is actually Vs, not Vi. Sorry. I make a mistake here. So you can write down it is actually Vs, not the Vi, because Vi is here. Vi means the voltage across the input resistance of the amplifier. This is our Vi. So you are asked to calculate the output current IL, because L means the load load resistance and output voltage, and as well as the voltage gain. Though you are thinking voltage gain already given, why should I calculate the voltage gain? Yes, this voltage gain is called the open circuit voltage gain. Don't mix up. One is the open circuit voltage, another is the actual voltage. So you think already voltage gain AV is given 100. So why should I again calculate the voltage gain? No, due to the presence of the RL, the output voltage is not the open circuit voltage. If it is, there is no any RL, that case your calculation, the AV is the 100. But due to the presence of the RL, the voltage gain will be changed. So what happened? You are asked to determine or calculate the output current, determine the value of IL equal how much, V output is equal to how much. Then you are asked to calculate the VI is equal to how much. And finally, you are asked to calculate the A means the amplification, V suffix means the voltage gain, AVS, voltage gain with respect to source is equal to how much. So at the beginning, you have to calculate the VI, otherwise you cannot do anything. So how to calculate? I already informed you, this is the circuit that is completely separate than the other part. This part and this part is separate. So there is a voltage source and it is a series circuit. And if it is series circuit, either you can calculate the current through the circuit by using the Ohm's law. The current multiple of Ri, you can find out the VI. Or maybe you can calculate it by using the voltage divider rules. I use the voltage divider rule. So what is the rule? Rule is very simple. You can memorize. VI equal how much? The total voltage of this. So VS multiple the resistance where we are interested to know the voltage. That is my R. I don't over the sum of these two resistance. So RS plus RI. So now you can write down VS is already given 10 millivolt. 10 millivolt multiple of resistance Ri is already given. Ri is equal to how much? 10 kilo ohms. 10 kilo ohms. K means the kilo ohms. Sometimes we don't want to write down the ohm symbol. Divide by RS is equal to 10 kilo ohm. 10 kilo ohm. 10 kilo ohm plus again I also 10 kilo ohms. So 10 kilo ohms. If you calculate, this value is equal to 5 millivolt. So already we done the one calculation, this one. It is better for every time when you ask this types of problem, you start to calculate the VI fast, because VI actually control everything at the right side or maybe output side. So right side is called the output side, and the left side, which is actually source is connected, is called the input side. So calculate the input voltage fast. Now the next step, you have to calculate the voltage AV into VI, which is actually voltage at the generator, output side generator voltage. So we can write down A V multiple of VI equal to AV is given, it is actually 100, it is unitless, multiple of 5 millivolt, it is actually 500 millivolt, or you can say it is actually simply 0.5 volt. So AV into VI, already know it is actually 500 millivolt. So 500 millivolts means this 0.5 volt. So why do I calculate this one? Because you know it is a simple circuit. Generator, the generator has the voltage which actually just we calculated this one, and this voltage connected R node and RL in series. So I can easily calculate the current by using the Ohm's law, because my voltage I already know now divided by sum of these two resistance. So I can say the current IL. IL is simply I can calculate IL